Okay guys, we move to the section B of NEET 2021. You know that in this year NTA introduced two separate section in NEET exam. The section A that contains 35 questions and section B it will have 15 questions where you have to answer only 10 questions. Okay, so let's see the section B of NEET 2021. Let's move to question number 86. It is a question from coordination chemistry. Maybe you can answer this question with respect to valence bond theory, or you can explain it with respect to crystal field theory. Here some complexes are given and with their magnetic moments are also given. So here first we have to deal with the ligand behavior of Cn minus and H2O. So Cn minus, it is a very strong field ligand. It is a strong field ligand. And we know strong field ligand means, strong field means it has the capacity to pair up the electrons in the same orbital. Whereas H2O, it is relatively weak field ligand. It is a weak field ligand, so it has not the capacity to force the electron to be paired up in the same orbital. So if we write the first compound, it is FeCN6 followed by 3 minus. So definitely if it is Fe6, so definitely the charge on iron atom, it becomes 3. Iron, it is 3 plus oxidation state. So 3 plus oxidation state means iron, definitely it is a 3d5 system. Now in 3d5 system, if we go for crystal field theory, 3d5 system in presence of strong field ligand, it will orient itself. Definitely the 5 electrons will stay in the T2G set, and T2G set, it will have T2G5 means 2 2 1. So T2G set, it will have 3 orbitals in degenerate level. So the 3 orbitals, they will first singly occupied, then there will be pairing. So only one unpaired electron is there. Since it will have only one unpaired electron, so magnetic moment, definitely magnetic moment mu spin only, we say, we use the formula root over n into n plus 2 Bohr magneton. If we put n is equal to 1, it is root 3, that means 1.73 Bohr magneton. Okay, so no doubt the first option, the first A, it matches with 4. So you can see the 4 we have in option A. And okay, so in the next case, if we find out the any one of these, say second, then we will get the answer. Okay, now let's see, in case of FeH2O whole 3 plus, FeH2O whole 3 plus, if we write FeH2O whole 3 whole 6 3 plus, so definitely here iron also is in 3 oxidation state. Iron 3 oxidation state means it is 3d5, and 3d5 in presence of weak field ligand, definitely weak field ligand, it will have T2G3 1 1 1 followed by Eg, it is 1 1. So definitely it will have 5 unpaired electrons, and 5 unpaired electron means it will have mu spin only. Spin angular momentum, definitely it is under root definitely 35, and 35 means 5.92 Bohr magneton. No doubt it is 5.92 Bohr magneton. So if we go for arranging it, definitely this will have the value 5.92. Think 5.92, it is So this will not be the correct option. We are getting the correct option. Definitely it is option 4. Now for further checking, you can go for the options. Question C. Question C, it will have definitely FeCN whole 6 4 minus. FeCN whole 6 4 minus. FeCN whole 6 4 minus. So here iron is in 2. Iron 2 means it is 3d6. 3d6 in presence of strong field ligand, it is T2G6 222. All electrons are paired, so spin angular momentum, it is definitely 0. So FeCN whole 6 3 minus, FeCN whole 6 3 minus, definitely it will have 0 magnetic moment, 0 moment. So let's see here also C3. So I am not going for a calculation of the last one. It is a weak field ligand with 2 oxidation state. Definitely it will have this value. So we have this correct option 4. So it is a quite it is a lengthy question but easy question. We also predict, before we have made some video before the NEET exam where we also predict that the section B, it may contain some question which will be some of lengthy part. So think that is a matching question from coordination chemistry, easy question, but it would take some time to solve it. Okay. Next, which of the following arrangement sequence is not strictly followed according to the property given below? So HF, HCl, HBr, HI. So as we move down the group, the bond length HX increases. So acidic property, bond becomes weak. So acidic property increases. So definitely HF weakest, HI strongest. So this is the property is correctly indicated. It is true. This option is correct. Now H2O, H2S, H2 in order of pKa values. Here also the same logic is applied. As we move down the group, the size increases, the acidity increases. Here the acidic property, if we say H2O, it will be less than H2S and it is H2AC and then H2T. This should be the acidic strength. This should be the order of acidic strength, but here given the pKa values. Now pKa, it will have inverse relation with acidity. Definitely. So the pKa order, if we go for the pKa order, so pK of H2O, it will definitely have higher value compared to that of pK H2S, and definitely it will be followed by. So this option, it is not a correct option. It is also given which is not strictly according to the property indicated. So correct option definitely it is option 2. So let us go for the check of the next options. NH3, PH3, SH3. So again down the group size increases, acidity increases. So definitely this is the correct order. CO2, SiO2, PbO2, oxidizing power. Now we know that as we move down the group, the +4 oxidation state, it becomes less stable, and in the above the +2 +4 state is more stable. So no doubt this is due to inert pair effect. So as we move down the group, the +4 oxidation state decreases. That means +4 states will have the more tendency to capture electron and itself it will undergo reduction. Therefore it will oxidize others. So the property indicated is correct. It has least oxidizing property, CO2. PbO2, it has strong oxidizing property. So oxidizing property increases down the group due to inert pair effect. So all these 1, 2 and 1, 3 and 4, they are correctly indicated according to their properties, and option 2, the pKa values is not given in the correct order. So as it is asked, which is not the correct option. So definitely it is option 2. Now a question from gaseous state. Let's check from gaseous state. Now the pressure, the total pressure is to be calculated. 4 gram oxygen and 2 gram hydrogen is mixed in a vessel of capacity 1 liter, which is kept in at a temperature of 0 degrees centigrade, and we have to find out the total pressure. So in finding out total pressure, definitely I have to find out the total number of moles. So moles of oxygen, it is definitely 4 by 32 means 1 by 8 mole. So 1 by 8 mole oxygen present. Moles of hydrogen, it is given by 2 gram, so it will be equal to 1 mole. So total mole I can write, total mole N, that is equals to 1 plus 1 by 8. So I can put this value, it is 9 by 8 mole. 9 by 8 mole. So we have to find out the pressure, total pressure. P, it is kept in a volume of 1 liter, that is equals to N at T. N, it is 9 by 8 into, it is 0.082 multiplied by 273. So pressure, I would calculate this value. Now for simplicity, I can go for, if we take it is 0.08, so 8, it will be cancelled, it will be 0.01. So multiplied 9 into 273, 3 9s are 27, 9 7s are 63, 65 followed by 6 and 18 the 24, decimal place this much atmosphere approximately. Now since we have approximated 0.082 as 0.08, so the value should be somewhat greater than 24.57. we should get this value 25.18. Again I have I have got discertain by finding such close options. Again NTA shows some immaturity to provide the options. Now if I would go for a multiplication of these exact terms, so it will take much time. So why the question paper setter, he has put such an option 25.18 and 26.02. This should not be done. In competitive exams, in the exams like NEET, it is not the target to whether the student can calculate, can do the division or multiplication in a very better way. So you should not provide questions like this. You should not set options like this. The options should have quite a difference. If there will be a difference, then it will be easy to predict the correct answer properly. Okay, this is the second time. This is the second time where in NEET 2021 we are getting some options which are very close, and there is no other way that you can go for. You don't have the calculators so that you can find out the exact result. Since we have no calculators, so I think this type of option should not be set. The question paper shows some immaturity in setting the options here. If I am not arrogant, I am telling again, by setting the options, by setting the question paper, NTA should have shown much cautiousness. Now next, which of the following molecules is non-polar in nature? Which of the following system is non-polar? So let us draw here. There is no way. You have to draw the structures. So POCl3, it's well known structures. POCl3, definitely POCl3, the dipole moment of 3 Cl bonds, that will not exactly cancel out the PO bond. So it is polar. Definitely it is polar. It is not a symmetrical molecule. Now CH2O, it is well known. So definitely due to polarization of CO bond, it will also have dipole moment. It is also polar. Now SB, that means it is group 15 elements which have 5 electrons in its outermost shell. That 5 electrons are involved in bonding. So definitely when 5 electrons are involved with 5 chlorine atoms, definitely it has got a trigonal bipyramid structure. It has got a TBP structure. So TBP structure, so definitely it is non-polar. The dipole moment, the bond moment created by these two, that will cancel with each other, and these 3 Cls in the equatorial plane, they will also cancel with each other. So definitely it is a non-polar system. And last one, if we go for NO2, definitely NO2, it will have the structure an odd electron species. We know that it is a coordinate bond and there will be a single electron. So again the shape is not symmetrical. Okay, so it is also it has got a bent shape, so it is also a polar molecule. So no doubt we have the correct option. It will be SbCl5. This is the correct option. And again, that's a very good question from organic chemistry, reagent chemistry, carbonyl system. A compound which has a keto group, a compound having a keto group, and as well as it will have an ester group. It is now reduced by NaBH4, sodium borohydride. We know that sodium borohydride, NaBH4, that will have the capacity to reduce aldehyde or carbonyls. NaBH4, it will have the capacity to reduce carbonyls. It may be aldehyde, it may be ketone, to the alcohols. Without disturbing the other groups. The ester group will remain undisturbed. Esters remain undisturbed. Ester group remain undisturbed. There will be no disturbance of ester group. So no doubt, see where the ester group remains undisturbed. Here ester group is remaining undisturbed and carbonyl is reduced to alcohol. So definitely we have the correct option. It is option 1. Here you find it is quite crazy in nature. This type of product cannot be formed. Here the ester group is reduced but carbonyl is remaining unaltered. Here both esters, this is also one carbon is increasing. This option cannot also be possible. Now again, question from kinetics. Now in kinetics, it is Arrhenius equation. So we have Arrhenius equation, no doubt. We have this Arrhenius equation, K is equal to A e raised to minus activation energy by RT. It is well known Arrhenius equation. If you take E base log on both sides, you will get, it will be ln A minus EA by RT. So here also it is asked the slope of the plot ln K versus 1 by T. So if we plot ln K versus 1 by T, ln K versus 1 by T, if ln K versus 1 by T is plotted, so definitely slope we get, the slope definitely it is minus E by E. Minus E by A minus E suffix A by R. So that value, it will be equal to this value. It is given, that is 5 minus 5 into 10 raised to 3. Now EA, definitely activation energy for this reaction, it will be 5 into R into 10 raised to 3, this much. Now what will be the unit? The unit, it is said that you put the unit in SI, so it is 5 into 8.31 into 10 raised to 3, this much joule, I think, this much joule per mole. So multiply this value, it is 5, it is 15, it is 41 into 10 raised to 3 joule per mole, or we may write it is 41.55 kilojoule per mole. So okay, we have an option, okay, it is 41.5. Option 1 is the correct option. Now again, a very good question is set. It is related to some reactions corresponding to their names, and generally we study this topic under name reaction. Now the first case, it is given benzene is reacted with a mixture of carbon monoxide and HCl in presence of AlCl3 containing little amount of CuCl, cuprous chloride. The product, definitely it will be aldehyde, benzaldehyde, and this corresponding reaction, it is called Gattermann reaction, Gattermann-Koch aldehyde synthesis. The product, it is undoubtedly, it is benzaldehyde. You know, it should be, it is benzaldehyde, undoubtedly it is benzaldehyde. Now in the next question, it is given RCOCH3 with NaOH. So it is a haloform reaction, no doubt it is haloform reaction, and in haloform reaction, what is happened? RCOCH3, no doubt this COCH3 in presence of NaOX, or we may write it will be Cl2 NaOH, I2 NaOH, Br2 NaOH, that CH3, it will be separated as CHX3, and the rest of the portion, it will be converted to salt. So no doubt it is haloform reaction. That is a well-known haloform reaction. Now again, an alcohol and carboxylic acid is reacted. Alcohol carboxylic acid is reacted. It is an esterification reaction. An esterification reaction, definitely the product we should get the R dot COO. It is CH2 CH3. It is an esterification reaction. Last one, it is also one of the common reaction. It is now definitely Helvollard-Jelinovsky reaction. We say it is HBZ reaction, very well known, where alpha bromination take place or alpha halogenation take place. It will be X followed by COOH. A very good question from name reaction. Now you can match the correct option. So definitely A, it goes for it matches with 2. A matches with 2. So see, A matches with 2, only one option is given. A matches with 2 with only one option is given. So if you know the A, so definitely C, you don't have to go through the other options. Very simple. You can now check. B, it will be, it is 3 haloform. C, it is esterification 4. D, it is 1. So definitely correct option, it is 4. Now again from thermodynamics, for reversible expansion of an ideal gas under isothermal condition, the correct option is, so ideal gas, if we go for isothermal condition, isothermal means isothermal no doubt delta T is equals to 0. Now once delta T is equal to 0, so we know that for ideal gas, internal energy, it's a change in internal energy, it's a function of temperature alone. So definitely delta U for ideal gas, it will always be 0. It will always be 0, whether it is reversible expansion or irreversible expansion, it is compression, anything. It will be for ideal gas temperature constant, it will be 0. Now what will be the delta S? Now delta S means delta S system plus delta S surroundings. Delta S surroundings. Now for irreversible expansion, the delta S total, it is always increasing. Delta S system, that will be greater than 0. That will be greater than 0. So no doubt we have the correct option delta U 0, but delta S total not is equal to 0. It should be the correct option. Now again a question from carbonyls or maybe aromatic aldehydes. In classroom situation, we always deal with 3 reactions. We always mention 3 reactions where the product is formed after formation of some intermediate. Those 3 reactions we say, one is Itard reaction, another is Stephens reduction, and other reactions are also there. These 2 are the major reactions where that will pass through some intermediates. So here a reaction CH3Cr O2Cl2, it is Itard's reaction. It is definitely Itard's reaction. Now in Itard's reaction, the intermediate, the product is benzaldehyde, but after the product is wine, it will not be completely oxidized to COOH, because a complex and chromium ester is produced. That chromium ester lock the lock the compound in the intermediate stage. Now you apply hydrolysis, you will get the benzaldehyde only. So this is option 2. No doubt this chromium ester, it will help, it will block the compound up to oxidation in the aldehyde stage. Again we find a question from environmental chemistry. If we study the previous year questions of NEET exams, you will always find a question from EVS, environmental chemistry. So here this time it is not also an exception. You will definitely we are getting a question from environmental chemistry. So sulfur dioxide, it is reacted with oxygen and it leads to the formation of sulfur trioxide. So this type of reaction, this conversion of sulfur dioxide to sulfur trioxide, this leads to tropospheric pollution. This is responsible for tropospheric pollution. So definitely A goes to 4. So A having 4, this will have 2 such options. Now HOCl, it will degrade to produce OH dot Cl dot. So that Cl dot combines with ozone in ozone layer. So that goes for a depletion of ozone layer. So definitely this reaction is responsible for ozone layer depletion. So definitely option B, it is 3. Option B, it goes to option 3. Next, if you know these 2 terms, then you are getting the correct option. So let's check the next, CaCO3 H2SO4. So this will also happen due to acid rain. We know the Taj Mahal, the pillars of Taj Mahal, that is made up of calcium carbonate. During acid rain, they get degraded, and the reaction occurs, calcium carbonate reacting with sulfuric acid, giving calcium sulfate. So Taj Mahal loses its brightness due to this reaction, and this is an adverse effect of acid rain. and definitely NO2 decomposes to NO and O, that is responsible for smog. So option C it is 1, option D it is 2. So we have the correct option. It is option 3. Now it is also all the informations, all the reactions, they are mentioned in NCERT text. So this is also I would say it is a copy paste question from NCERT text. Next, again here we are getting a question from conductance. Second time we are finding a question from conductance. It is given the molar conductivity of acetic acid is 20 Siemens centimeter square per mole inverse. What is the dissociation constant? Dissociation constant of acetic acid. Now we will try to find out first the molar conductance of acetic acid at infinite dilution. So that will be equal to definitely molar conductance of H plus and molar conductance of acetate ion at infinite dilution. Now these two values are given here. It will be 350 plus 50, it is 400 Siemens centimeter square per mole. Okay. Now the degree of dissociation, I can write the degree of dissociation alpha. It is nothing but the lambda value of acetic acid at any finite concentration here given divided by lambda 0, that is molar conductance of acetic acid at infinite dilution. The values are given, it is 20, it is 400, and if we find out this result, no doubt it is 1 by 20. 1 by 20 means it will be 0.05. So I can write it is 5 into 10 to the power minus 2. Now this is the degree of dissociation. Now at 0.007 molar concentration of acetic acid, the degree of dissociation is 0.005. It is much less than 1. So we have to find out the dissociation constant. So let's check how to find out the dissociation constant. So dissociation constant of weak acid, that is given by, it will be alpha square C by 1 minus alpha. Now since here in this case the alpha value 0.05, it is much lower than 1, so we can approximate it alpha square C. Now we can put this value alpha, it is 5 into 10 to the power minus 2 square into, it is 0.007 given. So no doubt I can find out this result, it is 0.007. So the result, it will be 25 into 10 raised to minus 4. We can write it 7 into 10 raised to minus 3. So it is 175 into 10 raised to minus 7, or we may write it is 1.75 into 10 raised to minus 5. So degree of dissociation of acetic acid, no doubt this value will be 1.75 into 10 to the power minus 5. This should be the correct option. It is a good question. It is a combination of ionic equilibrium and conductance. Now from which of the following pair of ions, which one is not isoelectronic pair? Isoelectronic means they have same number of electrons. So if we say about O2 minus and F minus all having stable neon configuration, and stable neon configuration means they have 10 electrons, so they are isoelectronic. Na plus, Mg2 plus, again they are also neon configuration having 10 electrons, so they are also isoelectronic pair. Now next it is given Mn2 plus. Now Mn2 plus, you see Mn2 plus means it is 3d5 system. That means it will have, Mn has atomic number 25. If you remove the 2 electrons, it will have 23 electrons. That will have the configuration 3d5. And we have Fe3 plus, that is 26, definitely it is also getting a 3D5 system, so they are also isoelectronic. These are also isoelectronic. Now if we write Fe2 plus, Fe2 plus it is 3D6, Fe2 plus it is 3D6 system, and Mn2 plus it is definitely 3D5. So they are not isoelectronic. They are not isoelectronic. So no doubt which one is not isoelectronic, it is asked. So our correct option, it is option 4. A simple question from, you can say, the very early part of atomic structure, very elementary part of atomic structure. Now the reagent in are given in the following reaction sequence. A reaction sequence is given, and in this reaction sequence NaNO2 HCl, so that will give diazonium. Okay, that diazonium is reacted with R, and definitely the N2 plus Cl minus, it will be released as N2. Now usually we carry out this process by utilizing hypophosphorus acid H3PO2, but here hypophosphorus acid is not given. Now which reagent should be used? Now in this case we use, if we react it with water, it will produce OH phenol. If we react with HI, then iodine may be introduced. If we use CN, HCN, CN will be introduced. So we have the option, it is ethyl alcohol. Generally, if you benzene diazonium chloride is heated with ethyl alcohol, in that case 2 benzene ring will be attached. That is, the biphenyl systems are produced. So when you deal with benzene diazonium chloride, in that case the heating of that benzene diazonium chloride with ethyl alcohol, that may lead to biphenyl system. So in that case we avoid it. But here the system is very much bulky. Two biphenyl systems, they may not be attached. So in that case you use ethyl alcohol, where only the hydrogen N2 plus Cl minus will be replaced by hydrogen. Okay, so definitely it will be ethyl alcohol. Now the correct option for the, again it is a question from solution, and for mixture of 2 volatile liquids, total vapor pressure of the solution, we can write it is vapor pressure of benzene, let it is P10 into X1, plus it will be vapor pressure of another, it is given, it is octane, it will be X2. Now P10 it is given, P10 benzene, it will have 280. Now mole ratio is given, so mole fraction it will be 3/5, plus it will be P2, it is 420, and its mole fraction it is 2/5. Simple, if mole ratio will be this, so the mole fraction of each component 3/5, 2/5. Now you go for a calculation, definitely it will be 5 5s are 25, 5 6, so it will be 18 6, plus again it is 8 5s are 40, and definitely it is 5 4s are 8 16 68, so it will be 1633, this much millimeter of Hg. Total vapor pressure of the solution, it will be 336 millimeter of Hg. Okay, now the last question, it is a very simple question from hydrocarbon. In preparation of hydrocarbon, the first we say we study the decarboxylation of carboxylic acids. Sodium salt of carboxylic acids are decarboxylated by using a mixture of NaOH and CaO. That mixture is called soda lime. That mixture is called a soda lime. If soda lime heating is carried out, this process is called decarboxylation. So definitely it leads to the formation of alkane. So our correct option, no doubt, it will be CaO. Okay, so here it completes the total discussion of section A and section B. We have tried to maintain our full work to make it correct in all respect. So if you like this, if you like our effort, then do share our channel, do share this to your friends, so that they can also check their questions, those who appeared in the NEET exam to 2021, so they can also check their answers. So it is a video for helping the students, not only for these year students, the students which will appear, they are appeared in the next NEET exam. So okay, thank you, do share, goodbye.